Okay, I was an engineer for 8 years before becoming a teacher, and this is the kind of problem that I did pretty much every day as an engineer, and it was figuring out what are different reactions that would happen given a certain beam. So a beam is just like something that supports weight, and you see them in buildings and bridges and all sorts of stuff. So uh, the reactions that I want to find here are the reactions at this support and the reaction at that support. There's 120 pounds on the beam, located 5 feet from the left side. Um, so if the load was right in the center, you could imagine that two people standing on the side each would carry half the load. If the load was like directly over one person, you could imagine that this person would take all the load, and this person wouldn't have to really hold anything, right? So what happens is when the load is located off the center of the beam, then we have to use some rules of physics, and in this case we call them static systems. Static systems are systems that are not in motion, so it's sitting there just doing nothing, right? If it was accelerating, like a car, right, the sum of the forces on it would be pushing it in one direction, but in this case it's not moving. So we say the sum, this is what that little funny letter is it's a Greek letter S, sigma, which is stands for sum. The sum of the forces in the y direction is equal to 0. So we add up all the forces that are in the y direction up and down, they equal 0. When we sum up all the forces in the x direction, they equal 0. And we sum up the moments, which are the twists, they also equal 0 if the system is static, not moving. So we say the y direction, the positive y direction is up, the negative y direction is down, the positive x direction is to the right, and the positive moment we'll say is clockwise. You could pick either way, but as long as you're consistent, it's okay. So let me add up all the forces in the y direction. So we have R1 is positive, plus R2 is positive, and then minus 120, right, because it's going down, is equal to 0. So this is the sum of the forces in the y direction. I'll rearrange the equation so that I can just have the variables on one side. So R1 plus R2, and then I'll add 120 to both sides, equals 120. And now if the load was right at the middle, you see that it'd be 60 plus 60 equals 120, but they're going to be different numbers. Okay, now the summation of forces in the x direction doesn't really tell us anything. There's no forces in the x direction, so it would be 0 equals 0, which isn't important to us. Okay, and then the next one tells us the moment. So I have to sum the moments about a point. So I'm just going to pick the point right in the middle. You could pick any point. So this is 4 feet and 4 feet because it's a total of 8. So in a positive clockwise direction, we have R1 is rotating it in that direction, right? So R1 times 4 feet. And then this 120 is also rotating it around that point in the positive direction. So plus 120 times, let's see, if this is 4 and this is 5, that would make this 1 foot away from that point. And then R2 is actually spinning it in the opposite direction, right? So if I imagine this is my point, and this is spinning it that direction, so minus 4 feet times R2 equals 0. Alright, and then I'll rearrange the equations. So 1 times 120 is just 120, and then I'll subtract 120 from both sides. So I get 4R1 minus 4R2 equals negative 120. Okay, so this is my first equation, this is my second equation, and I need to solve the system. Okay, so let me multiply this whole equation by 4, and then my R2 should cancel out. So 4 times R1 plus 4 times R2 equals 4 times 120 And then I add these two equations together. So 4 plus 4 is 8R1 minus 4 plus 4. That's what I wanted to happen, is that cancels out, so it's eliminated. Equals minus 120 plus 4 120s. So it's actually like I'm taking away 120, so it would be 3 120s. And I could multiply this out and make it 480 minus 120, which is 360. Yeah, so that's 362. Alright, so divide both sides by 8. And I get R1 is equal to, my calculator, so 120 times 3, which is 360, divided by 8 is 45. So the reaction, R1 is 45, and then I substitute this back into either equation, but this will be the easier one. 45 plus R2 is equal to 120, so R2 would be 120 minus 45, which is 75. So R2 is 75. So this is my solution to the system. My reactions would be 45 on this side and 75 on this side. And that makes sense because this side would be taking more load than this side because the load is closer to it. Okay?